And first of all, we're going to take the very original graph and we're going to draw it. So I'm going to add grid lines here. This is my absolute value graph. Label it y equals the absolute value of x. And then they have 1, 2, 3, 4 additional equations. So what we're going to do is we're just going to label beside each one of those what the numbers do. So you have nicer spacing than I do. So what I'd like you to do is beside draw an arrow from that 2, and beside that on yours, that's going to be horizontal stretch or compression. You're going to write horizontal compression because you would multiply x by 1/2. So you have space beside yours nicer than I do. We're just going to look at that right beside it there. So that 2 would be a horizontal compression. X would be multiplied by 1/2. Then in the next one, the only thing that's added new is the 1/4. That 1/4 will be a vertical compression, and you can write beside that one, that would multiply your y values by 1/4. The third equation, they added a +3. So I want you to highlight that 3. That's inside the function, so it's a horizontal translation. That will move things 3 to the left. And finally, in the last one, there's the +4. That would be a vertical translation 4 units up. Now we want to graph this final one without having to graph each one in between separately. That is a strategy. Some teachers will teach that way. They'll say, okay, let's compress it by 1/2. Draw it. Right? Then let's take the one that we compressed by 1/2, and now let's take that one and squish it by 4. Draw it. Now let's take the one that we stretched by 1/2, or compressed by 1/2, compressed by 1/4. Now let's move that one 3 to the left. Draw it. And then take that one and finally shift it up 4. And you have a lot of graphs that you're drawing, and it gets confusing. And so what we're going to do is we're going to learn a technique that we can go from the blue one to the green one with doing a little bit of mental math off to the side. That's relatively easy. First of all, to do this, we are going to choose 3 points on our original graph. For sure, we have to choose 0, 0. Can you see that that's like the most important point on the absolute value graph? Because that's where it changes from going down to going up. Then I'm going to choose 1 point on the right-hand side and 1 point on the left-hand side, because if I have those 3 points in my new graph, I'll be able to draw the V. Now you have some choice. I could choose 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. I have choices of which point I could pick. And all your choices will work, but some choices are better than others as far as doing mental math. So when I'm looking at what choice I'm going to pick, I'm going to tell you that I think right now, 1, 2, 3, 4, this will be a good point, and on this side, this will be a good point. And now we have to decide, why did I pick those points over 1, 1? Why would that be nicer to use? Well, if we look at what we all labeled, we have a horizontal compression, vertical compression, 3 to the left, 4 up. Looking at my compressions, do you see I have to multiply my x by 1/2 and my y by 1/4? So by choosing 4, 4, when I multiply that by 1/4, I'm going to get a fairly nice number to work with, not a fraction. If I chose 3, 3, and I multiplied by 1/4 for the y, then I would get 3/4, and it's not just a little bit more awkward to draw. So when we can make choices that make it easier for us, that's a good thing. Next, what we're going to do is we're going to write our 3 initial points, 4, 4, 0, 0, and 4, 4. And we did this before where we drew arrows, but what's different now is you're going to draw 2 sets of arrows. And in those 2 sets of arrows, our first arrows will always be all of our stretches and compressions. And the second set of arrows will always be our translations. In fact, if you have a reflection, that's also stretches, compressions, and reflections are in your first set of arrows. Your second set of arrows will be your translations. So we'll do our stretches and compressions first, find out where those points go, and then do our translations afterwards. In this case, what's happening? We need to multiply our x by a half and our y by a quarter. So above the arrow, I will write out what those stretches and compressions are. Then I'll go through and I'll figure out, if I multiply all my x coordinates by half, I'll start with those. I'd have -2, 0, and 2. If I multiply all my y values by a quarter, I will get 1, 0, and 1. Next, we do our translations. So above the arrows here, what are my translations? I need to go 3 to the left and 4 up. So I will write that above the arrow there as well. And then 3 to the left. Give me -5, -3, -1. 4 up, +5, +4, and +5. Again, take your time with this mental math. Because it is easy, you will have a tendency to try to think ahead what you should do next, and then you will make mental math errors. So take your time. We've got our new points. Now I'm going to label those points. -5, 5, -3, 4, and -1, 5. Label them. -5, 5, -3, 4, -1, 5. And there is the graph of the green one. It has had a horizontal compression, a vertical compression, translated 3 to the left and 4 units up. And we're able to graph something actually quite amazing. When you look at that equation, that looks like a complicated graph. It looks way more complicated than y equals mx plus b, which you were graphing in grade 10. And now you're able to graph complicated things if you know what the original graph looks like. We can now graph any square root graph, any absolute value graph, any x cubed graph, just by taking the original one and looking what happens to the points.